My name is Christopher Weller. I'm with Mistral. We represent Uvision out of Israel. Uvision produces the Hero 30 lethal miniature aerial munition, sometimes referred to as LMAMS. Next slide, please. So what are our major differentiators? Our major differentiator for our lethal miniature area munition is our X-wing configuration. So it acts more like a missile and less like an aircraft. The missile is approximately 3 feet long. It has a X-wing configuration, which allows us to have a 90-degree down attack angle, which is what our competitors are not capable of doing. So this is our major discriminator. Next slide, please. Why the need? Well, currently, our competition produces smaller, less lethal munitions that don't always carry out the mission. Don't hit the target, can't penetrate windshields, and so we have a little bit larger system that allows us to perform those missions at a greater level of lethality. Next slide, please. What you see here is a picture of the system in play. You'll see a launcher where the munition goes inside. You'll see a ground data terminal up on a tripod. So, and the soldier is carrying an operational control unit. Those are the three major elements. The soldier would take out his operational control unit, talk to the munition within the canister. It turns on, it launches, goes up to an altitude where it goes into a loiter. Its pre-programmed mission will carry out its waypoints till it comes to the target area. The aircraft then, with its day-night camera, would hunt for a target. So that's what the soldier is seeing on his operational display unit, chooses the angle of attack and type of detonation when it comes in contact with its target. Next slide, please. Main operational capabilities. I'm going to point out here it's flexibility of engagement, multiple angles of attack, operating day and night, operates with GPS, it's backpackable. Give you an idea of weight when I mean backpackable. The current munition, the Hero 30, in its canister weighs 11 pounds. So a normal soldier might have a backpack with 3 munitions. That's 30 pounds in weight. An operational control unit, just one of them, that's about 6 pounds. And a ground data terminal with or without a tripod, that's another 6-8 pounds. So that'd be his total carry weight. Next slide, please. Hero has a family of air vehicles. We have the Hero 30, which is the one we have over at our booth, at Mistral's booth. The Hero 120, which we have actually shown in Eurosatori. That's a larger anti-tank munition that would eventually be something that we would try to replace Javelin and TOW with if that requirement ever came out. So anti-tank. And then we have larger systems such as the Hero 400, which is more of a cruise missile type configuration that would be like an anti-building weapon. Next slide, please. Again, the elements of the system include the munition with the X-wing configuration, the launcher with the bipod, the operational control unit where you'd see the map for the user and the actual picture that the camera is seeing at that in real time. The ground data terminal on the tripod, giving you 10 kilometers worth of range, and you'll see a camera mounted in the front there in the center picture. Next slide, please. Its ground data terminal comes in 3 flavors. You'll notice on the right-hand side of the screen here, ground data terminal that the soldier can carry on his belt, that gives you 5 kilometers. If you take that same unit and you mount it up with an amplifier on the tripod, that'll give you 10 kilometers, and then we have a directional antenna that will reach out to 40 kilometers. So if you could imagine a soldier sitting back in the rear with the gear, and your special forces guys out in the field, well, that soldier could, in the rear, could launch the system, send it out 40 kilometers, and then the soldier, the special forces soldier in the field could pick up that munition in the air while it's flying and then take it out further. So one of the things that we are working on is being able to launch multiple munitions at a single time, where a operator in the field can then control all those munitions at one time, putting them into their individual loitering patterns, hunting for targets, designating, and then have everything attack at one time. And this can be done through our ground data terminals. Next slide, please. As far as training goes, we have a couple of different flavors. We have a rail launch system for just general training, teaching the soldiers how to fly the system inexpensively. We have a net where we can catch it, and we have a less expensive reusable tube, as well as a simulator on the operational control unit. We also have more formal, larger desk-size systems to train the soldiers with. One of the things that isn't on this slide is we also have a parachute version. We're going to be out at AEWE, the Army Expeditionary Warfighter Experiment, here in January. And at that, we're going to show the munition launch, hunt for targets, but we will recover using a parachute versus having a net. So it'll be something that we don't have in this presentation. Next slide, please. Okay, so we have a couple of slides that just basically show how the system launches. Again, the tube, the missile inside of the tube with its wings folded up. The 3 slides in the bottom show the munition coming out of the tube initially. As it's deploying, you'll see the sabots coming off of the wings. And then finally, the munition with its wings fully deployed, flying up to its first loiter point. Next slide, please. Are there any questions?
Sir, I'm going to ask the first question, then I'll get to you, Larry. So your system and the system that was briefed before, when you decide to abort, what happens to the round? In your case, are you letting the ordnance go, or?
Well, it is a munition,
right.
So we're not going to retrieve it. If during the mission you decide to abort the mission, it would fly to its crash point, I guess you could say, its ditch point. If the munition is in a loiter pattern and it reaches its bingo time, the soldier would be alerted, and then it would fly out to its ditch point at that point.
Okay, so you preset the ditch point up front.
Yes.
Okay, thank you.
Yes, sir.
Just to follow on to what Bill said, how do you transition control to different operators as the bird is in the air?
Well, obviously the controller in the field will have the proper communications coding to pick up the bird while it's in flight, and then it would take over. Does that answer your question?
Yeah, this really is who has the operational authority when the bird is basically in the air, and how do you transition it from the rear to the forward position, or is that seamless?
Well, that would be, I mean, obviously that's pre-mission planning. That's not something you're going to just arbitrarily do.
Anything else? Anyone?
Thank you very much.
All right, thank you, sir.
Appreciate it.